Hello everyone and welcome to our educational session. My name is Paul Arsov and I'm the founder of the Decentralized Web project. I'm going to talk about this and several other projects that we're working on in the end of this presentation, but the topic today is what is easy for humans is difficult for AI, and what is easy for AI is difficult for humans. Since the early 60s, AI researchers have observed a recurring paradox popping up across their projects, that the challenges that seem easy for humans are nearly impossible for AI, and those that seem difficult for people are relatively easy for AI to accomplish. Excelling at chess is a rare and difficult feat compared to putting on a shirt and tie, yet the former was mastered in 1997 by IBM's Deep Blue, whereas the latter is still largely unsolved. Many researchers noted this counterintuitive result in their work, but its label has been given to Hans Moravec, who articulated Moravec paradox in his book Mind Children, published in 1988. It has become clear that it is comparatively easy to make computers exhibit adult-level performance in solving problems on intelligent tests or playing checkers, and difficult or impossible to give them the skills of a one-year-old human when it comes to perception and mobility. This paradox persists through to the modern AI age. Authors like Minsky and Pinker have offered their own hypotheses for the phenomenon, and Moravec himself proposed an evolutionary explanation in his book. We're all prodigious Olympians in perceptual and motor areas, so good that we make the difficult look easy. Abstract thought, though, is a new trick, perhaps less than 100,000 years old. We have not yet mastered it. It is not all that intrinsically difficult, it just seems so when we do it. Put simply, we have had hundreds of millions of years of evolution to perfect our sensory motor systems. Yet, when it comes to refining our abstract reasoning capabilities, we are still novices. Had evolution better prepared us for hard thinking, we would presumably be more efficient at it. As an analogy, climbing a mountain is difficult for us, but easy for mountain goats, who have evolved refining anatomy and skills to master this domain. According to Moravec, logical reasoning of what mathematics is a subset is a domain of challenge for which our skills have not yet been attuned. A failure humans would be a better evolutionary fit. Though it has a certain intuitive appeal, there is a strange assumption behind his hypothesis. It implies that we have stumbled upon mathematics in the same way a mountain god's evolutionary ancestors stumbled across mountains, and we have yet to acclimatize. Another way of framing is um, that logical reasoning is an environmental niche that, unlike other animals, we have captured for ourselves, though imperfectly. This proposal is strange because mathematics and logic are not environmental niches. The challenges they present to us exist only in our minds. Even a logical realist, one that believes logic is a part of the real world, would say that numbers and logic exist everywhere all the time. We weren't presented with them all of a sudden as an external problem to which we adapted. They were always there, merely undiscovered. There's another issue as well. Logical reasoning is not itself a motivator of survival or competition, as you would expect from any driver of evolutionary adaptation. It isn't even a problem per se. Logic cannot eat you, kill you, hinder you, or steal your resources. It only presents issues when you fail to put it to effective use, at least relative to some other person who uses it better. The more effective your application, the greater is your advantage. Logic and reasoning are like tools we have invented, defined, and applied as a form of power and mastery over our world. We invent and reinvent the space all the time. There are solutions. In fact, calling logic a tool may be misleading since it implies like an extra finger or tail that it is embedded within our genetic code, whereas mathematical theorems and logical frameworks are all learned. When a new theorem is introduced, it spreads like a meme throughout its practitioners, usually without consideration for the subject's genetic history. All that is necessary to capture it is to have the basic ability to comprehend it and a bit of time and interest to understand it. Whereas some people have a greater genetic ability to integrate and apply a logical principle cannot be known before they are given a chance to try, and that itself cannot be determined until someone comes up with it. For all we know, had the ancient Sumerians lived in modern times, they might have had an equal ability to comprehend modern symbolic logic as we do today. In Moravec's defense, he would likely say that the various forms or details of logic are not themselves a set of evolutionary tools, as though they were built-in modules in the brain. Rather, they represent specific applications of fundamental reasoning skills that have evolved in humans more so than in other animals. Mathematics are one specific application, but it is the underlying ability that has really allowed us to master our world. Although it has been difficult to pinpoint exactly what is that underlying skill entails, we can at least enumerate some of its benefits. The first is that logic is abstract. Its rules can be transferred and applied in variety of specific cases without knowing the concrete details beforehand. 1 and 1 equals 2, regardless of uh, if they involve apples, cars, or countries. As a rational abstraction, logic also provides precision and correctness. Logical and mathematical conclusions are guaranteed. Reliability, consistency has often um, been noted as its greatest feature. Mathematics catalogs everything that is not self-contradictory. Of course, one of the recurring problems of logical thinking is that although it is clean and abstracted, um, it often doesn't match the messy reality of the world in which we actually live. The machinery of logic is only as useful as its inputs, and though often these inputs get oversimplified, exploring the real world is not so straightforward as it applies its in logical formulae. This hints at the true explanation for the Moravec paradox. When we derive new logical methods or mathematical frameworks, we're specifically trying to make it easier and more efficient for us to understand our world. Just as the formula of Newton's physics were invented to make complex dynamic motion easier to predict and work with. This always comes at the expense of full accuracy by ignoring many irritating details and consequences. But the overall benefits derive from the fact that unlike the messy real world, logic and math transpose our thinking into simplified and consistent model, which makes it easier to address and extrapolate. Though logic we have force consistently in our world. This is why logical reasoning in AI only works in simplified, self-consistent domains. Moravec even hints at this in his book when he noticed that Shaky, one of the Stanford's AI robots in the 60s or 70s, only worked in a dumbed down environment. Shaky sensors worked only when the scene consisted solely of simple, uniformed, colored, flat faces objects. So a special environment was constructed for this robot. It consisted of several rooms bounded by clean walls containing a number of large, uniformly painted blocks and wedges. And even today, machine learning models are far more likely to succeed if you narrow or constrain their tasks to clearly defined regular entities and processes. Even if Moravec hypotheses have been correct, the fact that evolution had not prepared us to perform logic still would not explain why computers and AI are so good at it. The answer is that logical thinking and any other kind of symbolic system is an invented structure that makes the world easier to work with, more consistent in its extrapolations. Thus, the fact that computers and AI can do it easily is no surprise. it is always intended to be so. Um, Easy is a relative term based on the skills the agent brings to the task. Evolutionary development certainly explains why humans, unlike other animals, can reason symbolically, but it needs not be invoked to explain why computers can reason symbolically, but it need not be invoked to explain why computers can reason well. Exploring and extrapolating the possibility of simplified, consistent rules and entities is precisely what we have built computers to do. A better analogy would have been to sports. It is not notably easier for both humans and AI to learn a sport that is for them to learn to live in general, because the terms, rules, and operations involved in sport are narrow and well defined. They represent a subset of what actually um, which makes their practice smoother and more straightforward and involved. In the end, the Moravec paradox isn't a paradox. We have conceived of symbolic systems to simplify, regularize, and universalize the fluid complexity of the world, and then designed machines to specifically carry out these same select operations. They do so well um, uh, that this should not surprise us. And with this said, I'm ending this presentation. And I like to come back to this, to the beginning of this presentation, when I told you that my name is Paul Arsov, and I'm the founder of the Decentralized Web project and several other projects. But first, the Decentralized Web project did build a decentralized communication advertising platform. As I just mentioned, it is monetized through advertising, which is very, very permissive. You, the user who come and join our platform, um, have to request viewing of advertising, and then you're presented with a screen where you view specific advertising for a minimum period of time, and then you have to click a button to advance to next advertising, and then to the next and the next, and so on and so on. We have our own blockchain instance in this project, and it is generating tokens for which we reward people who come to our come and join our platform and become users, and we reward these users for inviting other people to become users on our platform, and we also reward users for viewing one after another advertising screen after screen, and one after another, and more. And the tokens we reward our users are accumulating, and at some point they could be cashing on this token and get these rewards in fiat currency. With this said, I like to mention the URL and the name of the website of this project. It is decentralizedweb.org. Decentralized and web, these are two words, and they're put and typed all together. Decentralized web. Then there is dot and it ends with org. The meaning we put in decentralization is different than the meaning blockchain technology puts in decentralization. we view blockchain technology as fundamentally flawed and not suitable to drive the implementation of decentralization. And in our implementation of decentralization, it is done in a way of direct communication from user to user without going through a third party, namely a web server or a central point which collects information and then it provides this information back to users through websites or servers. With this said, I'm ending talking about this project, and the next project I like to talk about is our marketplace and collection of non-fungible tokens or NFTs based on three-dimensional objects. With 3D objects, there has to be special software which loads and displays the 3D object, and traditionally creators of 3D objects, they have been using standard software like currently there are two popular choices of game engines, one of them called Unity and the other one is called Unreal. But with this from the very beginning of our 3D NFT marketplace and collection of NFTs, we decided to build our own 3D software engine. And what it currently does, it opens a window on a computer screen that it loads, reads the 3D NFT file, and then it displays the 3D NFT on the window it open, and then it starts animating the 3D NFT in a way of moving it in a random fashion around the window it open. But in addition to this initial and basic capabilities of our 3D NFT software engine, it has multiple additional capabilities. The first additional capability of our 3D NFTs is the capability of speaking. Our 3D NFTs can speak in one of three different voices, a male voice or female voice or whisper kind of a voice. In addition to these three basic voices, there are three different flavors of voices. A voice can be spoken either in a normal speed or in a fast speed or in a slow speed fashion. The next additional and important capability of our 3D software engine is the capability of voice recognition. If you have a 3D NFT moving in a random fashion, being animated, you can then issue your very first voice command to this 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. Then you can issue following voice commands to the 3D NFTs to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go further away, zoom out, and start rotating. The next additional and important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to tell you their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply in a few sentences of who they are. You can ask the 3D NFT to describe something. For example, describe Web3 or decentralization, or the country called Russia. The last additional but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or cyan colors. Then you can come to the website of the project, and now is the time to tell you the name and the URL of the website of this project. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters N, F and T, and it is typed all together 3D NFT. Then there is dot, then there are two words, decentralized and web, typed all together. Then there is dot and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of the main page and every other page, you can see a number of links. One of these links point to links to accessories, and when you click on this, you're going to see that we are offering special glasses. When you click and order one pair of these glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue cyan. Then when you receive these glasses, you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and then you're going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D NFT software engine and collections, but I like to tell you about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance, and by having our own blockchain instance, we do not charge our users gas fees for deployments of the smart contracts for the 3D NFTs, and we do not charge our users for transactions of transfer of ownership from one user to another user. By having our own blockchain instance, we also allow our users to buy and receive proceedings from sale in multiple crypto coins. Currently, the choices include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and receiving proceedings from selling crypto, we have a second parallel and independent way of buying and receiving funds from sale, and it is done entirely in fiat currency. When you come to our 3D NFT marketplace, you click on the collection, you see all of your 3D NFTs, then you click on one that you like and want to purchase, and then you're going to be presented with a drop-down menu which is asking you to select between 4 different crypto coins and a fifth choice of paying with fiat currency. When you select payment with fiat currency, you're going to be asked to put the number of your debit or credit card, expiration date, and CVC. And when you click on the button to make the payment, then what is going to happen is there's going to be a transaction and conversion from your national fiat currency, which could be different than US dollars, and the payment is going to be converted from US dollars to from your national fiat currency to US dollars and deposit it in our bank account. Then we are going to follow this with a transaction and conversion like transaction and transfer of the initial ownership from our 3D NFT marketplace to you, and now you become the user of this 3D NFT. You can play with this 3D NFT for a while, and then you can decide at some point to put this 3D NFT for sale. You decide on the price that you want to put this 3D NFT for sale, and then you are going to be presented with some waiting time, and let's say there's a second user after a while who comes to our 3D NFT marketplace, and then they browse through this 3D NFT collection, and they click and like in particular and want to purchase the 3D NFT that you put for sale. Then they are going to be presented with the same screen of payment with fiat currency or payment with crypto, or the fifth choice of payment with fiat currency. Then they're going to go through the same steps of like putting the number of their debit or credit card expiration date, CVC, and when they click on the button to complete this transaction, the payment is going to be converted from their national fiat currency to US dollars and deposited in our bank account. Then we are going to make a transfer of ownership from you to the second user, and now they become the owner of this 3D NFT. Then we are going to make a transaction and transfer of the payment and convert it from US dollars to your national fiat currency and deposit it in your bank account in your national fiat currency. With this said, I'm ending talking about this project, and I like to mention the next project that we built and released, and this project built and released charging products for electric vehicles. With the charging with electric vehicles, we expect some rapid and exponential growth in the number of these electric vehicles released to the market, and we estimate that currently the electric vehicles, they are charged in a way similar to the internal combustion engines. When they come to gas stations, they load fuel and they pay and they leave. And in the same way, like owners of electric vehicles, they come to public charging stations with limited number of chargers. They connect the electric cable to the electric vehicle. They identify themselves to the charger by their debit or credit card. They request a start of charging. They wait for a period of time while their electric vehicle is charging, and then they pay and they leave. But we estimate that the number of these charging stations is going to become ultimately sufficient for the exponentially growing number of electric vehicles, and we propose so-called parking lot model, where the products like ones that we're building are going to be installed and mounted, and when like if the owner of electric vehicle is living in a residential building. When they come in the evening from work, they could park in their assigned parking lot, and then they could connect electric cable from a charger like the one we're building, and they could identify themselves to the uh, type of charger like the one we're building by their debit card, credit card, or near-field communication card, or near-field communication keychain token, or near-field communication ring, which they could be wearing on their finger, and they could request start of charging, and they could leave their vehicle to charge during the evening, during the night, and early morning while they're at home. But in the same way, these owners of electric vehicles, they could be working in high-rise office buildings, and these high-rise office buildings could be outfitted with ground floor parking lot or multiple underground floors of parking lots. And when the owner of the electric vehicle, they come in the morning to work in this office, high-rise office building, they could connect electric cable to the electric vehicle. They could identify themselves to the charger, and they could request a start of charging and leave their vehicle to charge during the morning, afternoon, and early evening while they're at work. With this said, I like to tell you the name and the URL of this website of this project that we're working on. It is power.arstec.com. Power is the ordinary word for power. Then there is dot, then there is a word which I can abbreviate it letter by letter. It is Alpha, Romeo, Sierra, Tom, Echo, Charlie, Hotel. Altogether, Arstec, then there is dot, and it ends with com. Once again, power.arstec.com. On the main page of this website, you're going to see 3 different surveys. One of these surveys is about hardware, the other one is about software, and the third one is about features. You can click and fill each one of these 3 different surveys, and this is going to tell you about your wishes and requirements for products, so that we can customize existing product or build a new product that could fit your needs. On this main page of the website, we also put a link to an article which is titled Gas Station versus Parking Lot Model. And in this article, you're going to read and see in very, very big details about the type of products that we are building, about their capabilities and features, and how this type of product, like the one we're building, can help not only the owners of electric vehicles living in residential buildings, but it could help electric utility providers. It could help electric transmission and distribution providers, and it could help owners of office buildings with their electric vehicle calculation and consumption, and aggregating of the use and request of the use, and grant the permission of use for a specific start of charging like scheduling times and etc. With this said, I'm ending talking about this project. I like to mention the next project that we built and release, and this project has two artificial intelligence agents, and these agents are designed to um, do like talking with each other and feed like requests and answers to each other. In this project, you, the human, uh, are just an observer of this interaction, and what you do is you can request the parameters of each one of these two different artificial intelligence entities, and assign each one of these two entities a gender, an image avatar, a voice with which they can speak, and a pitch with which they uh, speak in particular. You can also assign a specific large language model from a number of different large language models, and then you can specify the initial prompt of the interaction and the system prompt, which is going to persist from one interaction to another. The initial prompt is a one-time request, but the system prompt is the request which persists in interaction after interaction. And I can give an example. For example, you can assign the first AI entity a female gender, female voice from a number of female voices. Currently, we have 4 different female voices and 4 different male voices. And let's say the first AI avatar has a female voice from one of these 4 different voices. You can generate a female avatar for this AI entity. You can assign it with like the specific pitch with which this entity could speak, and you can request, for example, the initial prompt to be for this AI entity to be very seductive. And you can select the large language model, and in the specific prompt, usually it is like answer to questions and ask questions. And then you can add the initial request to be very seductive. Then with the second AI entity, you can select it a male gender. You can generate male image avatar. You can select also male voice pitch, which is usually a low pitch to convey male person or even masculine or dominant person. And you can put the system prompt, which persists from one interaction to another, to be very angry. And of course, it is going to have the persistent ask questions and answer questions as well. With this set, you can start this interaction, and then you can observe and enjoy this interaction. This type of project is in the category of entertainment and just for fun, and it is one of the very few projects in this category, because most of the AI projects are for therefore content generation, or for like business to business interaction, or for automation, or anything else like specific and non-entertainment alike. But after observing of this interaction going back and forth between two entities, you can stop this interaction, and then you have a choice of saving this interaction for yourself and listing this interaction at a later point. And the saving of this transcript is done at your local machine. But also you have a choice to share this interaction and publish the parameters of this interaction on the website of our project, and so that other users could see the parameters of this interaction that you have been doing, and then they could look and type the specific parameters that you put for this interaction, and they could request and enjoy a similar but not exactly the same like the interaction that you witnessed previously, because large language models have a requirement in their operation not to repeat themselves. So other users could see something similar but not identical. With this said, I like to tell you the name and the URL of the website of this project. It is ai2ai.decentralizedweb.org. AI to AI is typed in a way of the letter A followed by the letter I, followed by the number 2, followed by the letter A and I. And it is typed all together, AI to AI. Then there is dot, then there are two words, decentralized and web, and they're typed all together. Decentralized web. Then there is dot, and it ends with org. Once again, aa2a.decentralizedweb.org. I gave an example of interaction between seductive female AI entity and an angry male AI entity, but the interactions could be very different. Like, for example, the first AI entity could be a user looking to buy a washing machine or a car, and the second AI entity could be a salesperson trying to sell a washing machine or a car to this user who is looking to make purchase. The interaction could be also any other different interaction between the two AI entities. With this said, I'm ending talking about this project, and I'd like to mention two other projects which do not yet have released website, and like they do not have articles or information published about what we're working on. The first project that we are working on is about counting the number of tokens that you as users spend for using AI services provided by a large commercial AI services provider. And large companies providing AI services like OpenAI or Anthropic or Google or many other providers of AI models, like they work sometimes on flat monthly fee that you pay month by month, but many of these large commercial providers are going to switch early or later to payment by number of tokens, for example, millions of tokens that you are consuming. And with this type of payment, usually the bill is coming in the end of the month, and sometimes it comes as a big surprise to you that you have to pay hundreds or thousands of dollars unexpectedly. This is an unpleasant surprise, which our AI agent could spare you from by telling you of your daily or weekly or monthly like consumptions of tokens from multiple providers of AI, commercial providers of AI models, so that it could spare you unpleasant surprise, and you could know exactly the count of tokens that you consumed for a period of time or during the day, and what is the expected bill which you're going to be presented with. And the second project that we're working on and we're building is about building an automation agent which is going to you can request a start of this automation agent to start recording your interactions, and then you can put manually one after another a sequence of steps and interactions, and at the last step you could say that this step is requiring user confirmation, and after this user confirmation then you could make the last step, which could be, for example, a payment for a specific purchase, and then at this point you can end recording of this sequence of interactions, and you can label this interaction with a specific label. Examples of this type of interactions could be like going to the websites of several different food food stores, and then you can select one of these websites to buy a specific type of food, and at the last point you're going to represent it with a screen where you put the number of your debit or credit card, or to use your safe debit or credit card, and a button to click and make this purchase. Then you can notify the AI agent that this step is requiring user confirmation, and then when you can click to complete this interaction and have the food item delivered to you. Then at this point you can notify the AI agent as the end of this recording of this interaction, and you can label this interaction with buying with this specific food item. Other examples of interactions could be buying a ticket for a specific concert from a range of dates coming at a specific location. Or you can buy an airplane ticket from one or more providers or airlines, and at the last step you can request user confirmation, and then you can label this interaction as buying of airplane ticket uh, from a specific airline or number of airlines and websites of travel agent uh, like airfare providers and from a specific range of dates and times and specific starting and starting location and destination and return back. With this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day, have a nice evening, and goodbye.